This video we are going to solve this integral using the trig sub. So with the trig sub we can start off by let x to be equal to tan of theta, right? So this is the substitution that we are going to use. So let's find dx. So dx is going to be secant square of theta d theta. That is the differential of tangent of theta. And then with the change in limits, when x is 0, that is the lower limit here, we have theta to be equal to the tan inverse of 0, and that is equal to 0 when x is equal to infinity, which is the upper limit. Theta is going to be equal to the tan inverse of infinity, and that is equal to pi over 2. So we can take the integral from the x world into the theta world. Let's do that here. So the integral is now the integral from 0 to pi over 2 of 1 all over 9 plus 25x. X is tan of theta, so that is now tan square theta because it's x squared, which is multiplied by the square root of 1 plus x squared. X is tan of theta, so tan square theta times dx, and dx is what? Secant square of theta d theta. That is dx here. Now that we have this, we have to know this identity that 1 plus the tangent square of theta is equals to secant square of theta. So 1 plus tangent square of theta is secant square of theta. So we can plug that into our integral. So I integral is going to be equal to the integral from 0 to pi over 2 of 1 all over 9 plus 25 tan square of theta, and this one is the square root of secant square of theta times secant square of theta d theta, which is equal to the integral from 0 to pi over 2 of 1 all over 9 plus 25 tangent square of theta. This one in a square root, the square will cancel the square root, leaving secant of theta times secant square of theta d theta. And we have I to be equal to the integral from 0 to pi over 2 of this secant will cancel one of the secant on top here, leaving one secant of theta on top, divided by 9 plus 25 tan square of theta, this theta here. Now what is secant of theta? Secant of theta is 1 over cosine of theta, right? So the numerator, I'm going to write 1 over cosine of theta, and the denominator is 9 plus 25. Tan square of theta can be written as sine square of theta over cosine square of theta, the theta. Now we have to multiply the numerator and the denominator by cosine square of theta. So multiplying the numerator by cosine square of theta, we are going to have cosine of theta all over, multiply the denominator by cosine square of theta to maintain equality. That is 9 cosine square of theta plus 25 sine square of theta. That is just multiplying the numerator and the denominator by cosine square of theta. And now this one, we know that this very famous one, we know that cosine of theta, cosine square of theta is 1 minus sine square of theta. So I'm just going to plug that into our integral. So I is the integral from 0 to pi over 2 of the cosine of theta all over 9 into 1 minus sine square of theta plus 25 times sine square of theta and the theta. That is the integral from 0 to pi over 2 of cosine of theta at the numerator, divided by 9 minus 9 sine square of theta plus 25 sine square of theta, the theta. So what we have here now, we have to combine the numerator integral from 0 to pi over 2 of cosine of theta divided by, this is 9 minus 9 sine square theta plus 25 sine square theta is 16 sine square theta, the theta. And now let's do a u sub here. It will become clearer if you do a u sub. We are now going to let u to be equal to sine of theta So du is cosine of theta d theta. That means in place of cosine of theta d theta, I'm going to replace that with du, which is here. And now next one is to find the change in limits. When theta is equal to 0, u is equal to the sine of 0, which is 0. When theta is pi over 2, the upper limit u is the sine of pi over 2. That is sine of 90, which is 1. Now the integral can be taken into the u world. So I is going to be equal to the integral from 0 to 1 of cosine of theta d theta is du. So I'm just going to replace that with du all over 9 plus 16. Sine of theta is u, but there are two of them multiplying, that is u squared. Now this one is now easy to integrate. What I'm going to do is that I'm going to factorize 16 out of the denominator. So I have 16 into, when I factorize 16 out, this is 9 over 16, right? Plus u squared, this one du. And 1 over 16 is a constant, it comes in front. You have 1 over 16, the integral from 0 to 1 of 1 all over u squared plus 9 over 16 du. So I is going to be equal to 1 over 16, the integral from 0 to 1 of 1 all over u squared plus 9 over 16 can be written as 3 over 4 all squared du. And now let's compare this one to the arctan integral, which says the integral of x squared 1 over x squared plus a squared dx. This one is equals to 1 over a, the arctan of x over a plus the constant of integration. So we are going to solve this integral using this arctan integral. This integral I is 1 over 16, 1 over a here is 3 over 4, tan inverse of x here is u over a, which is 3 over 4. The limits of integration from 0 to 1. This 4 cancel, leaving 4 here. I is going to be equal to 1 over 4 times 3, which is 12. The tan inverse of the reciprocal of 3 over 4 is 4 over 3, so 4u over 3. The limits of integration from 0 to 1. Now I is going to be equal to 1 over 12. You cannot plug in your limits. The upper limit is 4 over 3 times 1, which is 4 over 3, minus plug in the lower limit, which is tan inverse of 4 over 3 times 0 is 0, which is equals to 1 over 12. The tan inverse of 4 over 3, tan inverse of 0 is 0. Therefore, I evaluates to 1 over 12. The tan inverse of 4 over 3. This is the answer to this integral. So when we go back up, that is to the very top, this one evaluates to 1 over 12. The tan inverse of 4 over 3, like this. So this one is the answer to this beautiful integral. So if you find that helpful, please give me a thumbs up. Subscribe to my channel Calculus Diaries for more engaging content on calculus integrals. I thank you so much for watching this video, and I will catch you up in the next one. Bye bye.